Hello Internet, and welcome back to another video. This happens to be a special video because this formula is one of the most beautiful in all of mathematics and is actually my YouTube profile picture. Showing that this is true really only requires some basic calculus and algebra and is actually quite simple. That being said, let's get into the video. So, Euler's formula is something that's used in complex analysis a lot, which is much higher level than anything I know, but it says e to the I theta is equal to cosine theta plus I sine theta, which actually gives us a result that is quite beautiful when we plug in pi for theta. So what I want us to recall for this video is just some very basic Taylor series, Maclaurin series actually. The first one is e to the x equals the infinite series from 0 to infinity of x to the n over n factorial, which is of course equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on. Also sine of x, which is equal to the infinite series from 0 to infinity of negative 1 to the n x to the 2n plus 1 divided by 2n plus 1 factorial, which basically looks like x minus x cubed over 3 factorial plus x to the 5th 5 factorial, and so on. That would actually be a minus. And then lastly, cosine of x, which is equal to infinite series from 0 to infinity, negative 1 to the n, x to the 2n divided by 2n factorial, which is kind of similar to sine x, and it's 1 minus x squared over 2 factorial plus x fourth over 4 factorial minus dot dot dot. And then I just want us to recall what this I right here is. So we know that I is equal to the square root of negative 1, I squared equals negative 1, I cubed equals negative I, and I to the 4th equals 1. Okay, so now we can really get started with this problem. What I'm going to do first is I'm going to write out e to the I theta, and something we can do with Taylor series is just whatever's in this exponent, just substitute it in for this x right here. So e to the I theta as a Taylor series is I theta, or I'll write it with the series, oops, it's the infinite series from 0 to infinity of I theta to the power of n divided by n factorial. So now I'm going to just expand this, kind of how we did up here. I'm going to write, just remember that I theta goes wherever the x is. So 1 plus I theta plus I theta squared over 2 factorial plus I theta cubed over 3 factorial. And I'll just write out these next terms. Oops. I'm going to go up to 7, I think, because that'll help us really show what's going on. Okay, there we go. So what we're going to do is we're going to simplify this. We're going to distribute these powers here to both things in the parentheses. And what we're going to get is 1 plus I theta. That stays the same sign. Remember that I squared is negative 1, so that I disappears. We get minus theta squared over 2 factorial. Then remember that I cubed is negative I, so we get minus I theta cubed because the 3 goes to the theta as well, over 3 factorial. I to the 4th power is 1, so plus theta to the 4th over 4 factorial, and then theta, or I to the 5th power is just I, so plus I theta to the 5th power over 5 factorial. And now we're just going to get the same pattern again, because we'll have pretty much an I squared and an I to the 4th here multiplied by each other, which will just give us negative 1. And so we get minus theta to the 6th power over 6 factorial, and then minus theta I theta to the 7th power over 7 factorial. And that pattern will just keep repeating. So now, what I'm going to do is I'm going to separate the things with imaginary numbers and the things without them. So I'm going to get 1 minus theta squared over 2 factorial plus theta to the 4th over 4 factorial minus theta to the 6th over 6 factorial plus, and then you doing the same thing with the i's, we get I theta minus I theta cubed over 3 factorial plus, I theta to the 7th over 7 factorial minus, or that should be a 5, sorry, minus I theta to the 7th over 7 factorial. And that pattern will just keep repeating, because those powers of I will give you the same results once you go past 4. They'll just keep repeating. Now the last thing I'm going to do, I'm going to rewrite this here, 1 minus theta squared over 2 factorial plus theta to the 4th over 4 factorial minus theta 6 factorial. And what I'm going to do is I'm going to factor out an I here, so we get plus I times theta minus theta cubed over 3 factorial plus. And what we're going to see is that these really start to look like, not start to look like, they are the Taylor series for sine of x and cosine of x. So this one right here, that's cosine of x. So we get, but it's theta instead of x, so we get cosine theta plus I times, and what's this? This is sine of theta. So we get I sine theta. Therefore, e to the I theta equals cosine theta plus I sine theta. So that's the result we're looking for. Now, another result we can get from this is one of the coolest, I think, one of the most beautiful formulas in all of mathematics, and that's when we plug in pi for theta, we get e to the I pi equals cosine of pi plus I sine of pi. Now sine of pi is 0, so this is just going to go away. Cosine of pi is negative 1, of course. If we look at the unit circle, it's all the way negative 1. So we get e to the pi times I equals negative 1. Now, if we add 1 to both sides, we get e to the pi I plus 1 equals 0. Look at that. Almost every, I mean not almost every, there's so many, but many of the major constants are showed here. E, pi, I, 1, and 0. That's why this is such a cool result here. So anyways, that's one of my favorite results in all of mathematics that I've learned so far. And I just wanted to share this quick video so you can appreciate it too. Thank you for watching.